Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. No engines, no libraries. It's just our code here, running the entire thing, right down to rendering the pixels. We don't even call the GPU, if you can believe that. Right now we're in the middle of doing some debug code for ourselves. We decided it was time to have some nice debugging tools that we could, use to better visualize what our code is doing and make it easier to find bugs that are in the code when we have them, or even just to even know that the bugs are there. Sometimes you can have very subtle bugs, and if you don't have good visualization, there will be something wrong, but you can't, it's hard to put your finger on it, or some things are acting strange, you don't really know why, and stuff like that. So good debugging code can be very good for a number of reasons. It shortens the debugging time, but also lets you find more total bugs than you would have found otherwise, especially kind of subtle performance bugs or things like that. That are kind of tricky to find sometimes with traditional debugging. So that's what we're doing right now. This is going to be pretty much all coding here because we have a bunch of stuff that we want to do, so there's not going to be much exposition. We already talked about it on the previous 2 days, so it's going to be all coding, and today is day 178. If you would like to follow along with the coding at home, and you were one of the folks who pre-ordered the game on handmadehero.org, you will want to unpack day 177. The source code from day 177 is what I'll be starting on here on day 178. So go ahead and do that, and you will be where I am right now. And where am I right now? Well, let's take a look. Let's take a look. If you remember correctly, last time we had just kind of put in the ability to do some automatic debug, automatic performance counter stuff that improved upon the stuff that we had before. But there's a bunch of stuff that we would like to do to this. For starters, we were just using the font code that we had in there before that we wrote, but that was using a very large font, right? That we were using for testing so we could see the glyphs up nice and close and all that sort of thing. And so obviously, if you look at that, that's not going to be a very effective way to do a debug display, to say the very least, because I mean, nothing for nothing, but you ain't going to fit a lot of debug information on the screen if that's the size of your font. So what we probably want to do at this point is go over to our asset packer and ask it to pack up for us a tiny font, a font that's going to be legible, barely legible for us, but that fits a lot of information on the screen at once. I think that's basically what we're going to look for. And maybe we want also a monospaced font, because we don't have really much in the way of any kind of advanced typography. So, our debug printouts are not going to be laid out pretty or anything like that. So we may want like monospaced or something so that we can line things up manually with spaces, old school editor style, which, we've talked about this before, which is probably why, editors these days still use monospaced fonts, is because they don't have good typography. So we don't have good typography either. And so our debug layout should probably be something in a monospaced font, I would think. So let's just get that going. Let's just, do a little bit of that first, just so we can kind of be in a better position to start talking about what we want to do with that debug display, how we want to get that kind of working a little bit more fully. So in the asset packer here, I think we have a thing that writes out fonts by themselves. Am I wrong about that? I think this is it, yeah. So you can see this writing out the fonts here. So what I'd like to do is, I'd like to have some way, probably of picking fonts. I guess we haven't really done much with that yet in terms of picking fonts, so maybe we want to do that as well. What we could do here is in our handmade asset.h, we don't really have much in the way of support for like selecting things specifically, but our tag system could totally be used for that, right? We can make basically a set of enumerated tags, for lack of a better term, right? And we can go ahead and sort of say that we want a specific type of font. So if I look at the file formats, for example, we've got sort of these things: spacing, direction, Unicode, code point, that stuff. We could have something in here that's like font type, right? And we could say something in here where it's like 0 is a debug, or like the default game font. 1 is like the debug font or something, or maybe we want to do something a little bit further up, so in case we want to use something else. We could do something like this. In fact, we could even do something like this, right? Asset font type. And we could do like font type default and font type debug, you know, and we could just use those. So if we wanted to do that, again, we really shouldn't have to, you know, we haven't really done a whole lot of testing of our asset system, but I suspect that all of this stuff is probably totally fine. We'll find out. But we'll go in here and just say, okay, I want to set this to be the default font or something, right? And then I can go in here and sort of do the exact same thing, you know, with a different font. So I can just say, all right, let's make another font here. Maybe I can even just kind of bracket that off. I could even make this just be a thing that we do for all our fonts. So I could just do like something like internal void add font like this, and just kind of grab this whole thing, you know, and do that. And that way I can just have different fonts where I can say which fonts I want them to be. So I can just say, all right, you know, what's the font file? What's the font name? You know? So then in here we just go like so, add font. And again, I'm not really doing anything interesting here. All I'm doing is just, you know, trying to make it so it's easy for us to have two fonts in here, which we've never really tried before. Suppose we should have probably tested that before we moved on. But, you know, what are you going to do? Got to do stuff as it comes up. So, yeah, you know, start with that. And we can say, now that we've got that font name, font file and font name, let's go ahead and compile this and make sure this all works right. Okay, it's got to have the assets, obviously. So we'll pass that in there. And then, yeah, looks good. So if we want to add a new font, so this tag here, we'd want to pass that font type in, right? Because we don't know what the type should actually be. So we can say, you know, which type of font we want, and there's the type there. So we can just go ahead and say, all right, that's going to be this. And then we can do another one where we pass font type debug. And the font type that we would want for debug, you know, I guess I'd probably just use this one here that we've got, Liberation Mono, like C Windows fonts Liberation Mono regular, you know, something like this. And so in there I would just say, okay, you know, C Windows fonts Liberation Mono, like that. And then, you know, I don't actually know what the name of that one is. I think it's just Liberation space Mono. Could try it, Liberation Mono. But I guess I could also see Windows fonts. Oops. I could just see what it says the name of that is. So where is Liberation Mono? Liberation. Boy, there's a lot of fonts on here. I think this machine has had lots of things installed on it. Like, you know, it had Adobe Premiere on it at one point. And like other packages like that. Because we used to use it for other things. And so now that it's been like kind of replaced as a streaming machine, it doesn't actually do anything else. All these fonts, you know, are still in there. Yeah, so just Liberation Mono. So I think that's fine. That's what I use in my editor, so maybe we'll use that. So if I do Liberation Mono, let's go ahead and compile this. Add tagged, tag font type. Let's see. Going from asset font type to real32, possible loss of data. Well, you know what? Let's just go ahead and cast it then. No harm, no foul. So now that we've done that, I don't know, that's going to pack some font stuff in there, and that's fine. So we'll go ahead and see what happens if I run it. We'll go to the data directory, and we'll run build test asset builder. So yeah, let's see what happened there. Well, the test fonts got about twice as big, which is, I think, exactly what we would hope for. And now, of course, we still haven't quite done we still haven't picked a smaller size. So it's still going to be huge, but at least we can test the dual font thing, which will give us some perspective on whether we're working right. And then we can go ahead and try to add that size in there separately. Oh dear. So we do have some kind of a bug here, it looks like, right? Oh, you know what? Well, no. I rebuilt the fonts, and and then we reran. So I'm not sure why we're getting a bug there. Oh dear. So our asset count is massively wrong. So something very bad has happened during loading these files, as you can see. Well, I guess we don't necessarily have a problem with the tagging, but we do have a problem with something else. So why are we getting that problem? Why are we expecting to load a lot more of these than we actually loaded? That's a little bit weird, right? Well, we know we merged multiple files properly, so I guess I don't know why this would have had any particularly unusual sort of operation to it. I don't know why we would be getting some kind of a weird situation just from that. However, you know, let's just go ahead and step through it and see what our actual problem is. What I'd like to do first is I'm going to go ahead and delete everything but the font one, just so we can narrow it down to one thing and just see if there's, you know, just make it a little easier on ourselves so we don't have to debug all these other guys at the same time. So we've got like test 1, test 2, all that stuff. Let's just get rid of those. So now all we have is testfonts.hha. So all we're doing is loading the fonts. It says that we should be expecting 201 fonts assets to come in. Instead, we only get 101. So we're basically, you know, we're missing essentially, well, you know, you can kind of see what's happening there almost already. We're missing one entire character set for some reason, right? I mean, it's just gone. So something is a little bit fishy. So I'm going to go ahead and step in here and see if I can see what's going on. Hopefully it's something not particularly too nefarious. So as I come in here, let's see which desk type ID I'm actually looking at. So this is the asset type count, right? So we only have one file. Here is the file. It should be the test fonts HHA file, right? And let's see what it's got. The asset type array, how many of these actually are there so far in the file? Well, let's look at the header. So the asset type count is 19, which seems a little odd because I don't know why it would have all those additional types in there. I guess maybe we just kind of spammed those in or something like this. I'm not entirely sure. The asset count is 201, which I think is what we would expect, 100 from each font, and then the 0, the reserved 0. There's the tags. Having 44 tags does seem a little bit odd, right? Because it's a bit strange to only have 44 tags when you have this many assets. Because each of them should have, like where are all those tags coming from, right? That's a little bit odd, I think, in and of itself. Asset types, I know what's going on. Right. Tag count. I'm looking at the wrong one. Tags is just the offset in the file. I just got confused there. So don't worry about that. I take back what I said. The tag count of 3, that seems fine. Asset type count, we probably just write them all out even if they're 0, so that's fine. So all of this actually looks totally reasonable. At first blush, I'm actually fine with it. I just got a little confused reading it there. Anyway, so let's continue on. When we look here, we're not reading font glyphs yet, right? We're just reading type ID 0. And it turns out there's none of those anyway. So since there's none of them, we're not actually going to do anything there, and that's fine. I think that's going to be true pretty much the whole way through, right? It is a little weird. So desk type ID, let's see here. Let's go through to see where we're at. So under the file indices, under the source index, the source type ID should be something else, right? Why are there so many source types with 0 on them? Like, why is that type ID always 0? I feel like our thing that writes out our assets is doing something a little bit wonky. Wouldn't you agree? I I don't like the look of that. That looks just kind of wrong. So I would like to take a brief look to see how it's actually writing that out. It's writing out this asset types array, right? And so what does it actually do there? Where is that asset types getting set, right? And I'd like to kind of, in fact, you know what I can do too? Before we go any further in this, let me just jump over to that asset processor and let's just actually see what it's doing. Because it seems like it's just not, it seems like it's actually a little janky. And even though this may have nothing to do with the bug that we're seeing, when I see something janky, I prefer to go find out what's going on because, you know, I'd like to always understand what the code is doing, and if something doesn't make good sense, I should at least figure out what it's doing first before declaring that it's fine, you know? All right. So yeah, it looks like the way this works is it never actually initializes the type ID for these guys or something. Like the type ID maybe only gets initialized if the thing is ever used. And that seems a little bit odd. But there it is, and yeah, I guess that's exactly what would happen. It grabs that particular one there. Okay, you know what? This is probably the bug. Because this probably happens. Yeah, that happens twice. Right? So we don't really want to do that way. I don't know if you can see that. So that actually, if that's not the bug, it is at least something that would totally cause the bug. So it's at least part of the, it is at least totally wrong and would do exactly what I just said. Because if you look at what happens here, every time we go to start adding a particular asset type, when we do begin asset type, you can only call that once. And so I think I'm calling it twice. And so we should probably make it so that, you know, we should probably make it so that that's an error at the very least. I would think. Let's take a look here at how that works out. So in the test asset builder, begin asset type. In the test asset builder, this thing is going to get called when we do the add font, right? I'm pretty sure the add font actually just does that. Oops, add font. Yeah, you can see it does the begin asset type, and then you know you can't reopen these asset types, right? So that's just not cool. And you know, I don't know if I really want to upgrade this thing because, like I said, this is just kind of a. It's not really meant to be a. It's not really meant to be a full-fledged system. You know, it's just supposed to be an example of one. So I don't know that I really want to spend a lot of time making it better than it is, but that's not going to work. Like, right? That's not going to work at all. And so what we would want to do, for example, is we'd want to go through like the fonts. And so maybe, you know what, here's a pretty easy way that I could do it. I could just make it so that in here we do those fonts like as a group, right? So in here I just go through for each font and do this, right? So I go like, you know, font index 0 less than like array count fonts or something, font index or whatever. You know what I mean? Add all the characters, do the little dance, have a little party. And then in here, when we begin asset type, just do the same thing, right? That seems like a reasonable compromise, you know, something that's not too much of an annoyance. And so then what I can do is in here I can say, okay, loaded font, you know, fonts, bracket, and then I can just go ahead and load the actual fonts like so. Oop. There we go. And then what I would need to do is I'd need to store, I guess, another piece of information like, you know, I don't know, desired font, something like this. I would need to store which of the tags I want with it there, I guess. In fact, maybe I don't even want to do that. Maybe I want to be able to do the tagging more explicitly. So probably what I'd do is I'd still just do it this way, and then I'd add the tag down here, right? I'd do the tag adding down here. So something like this, add font asset, and then I'd pass the font, right? Like so. Oops. and then I'd add the tags that I want for that font. Yeah, that seems fine to me. And I suppose I could also even do something if I was so inclined. I could actually make it even a little bit different than this. I could make it so that I just pass which font I want to this thing and have this actually be a little routine, so I don't even have to put them in an array. But I don't know. I don't know if that's worth it. So I'll just go like this for now and leave it. That seems fine. So then that'll load those fonts. And then we'll have loaded font. Font equals fonts plus font index. And that'll just enumerate over the fonts. So, yeah. So that we have all the characters for them. And that seems fine. Again, this is not really supposed to be particularly good code, and isn't, so that's fine. That's going to be a comma. And cannot to a pointer to a pointer. Ah, all right, well. I'm not sure what is... Shouldn't that be an array of pointers to loaded fonts? So load font, or, oh, does load font actually just return a loaded font? No, that's right. So that should be fine. What is the complaint? Loaded font star star to loaded font. Oh, yeah. Sorry. Just a little mental break there. All right, so now what we've got to do is we have to fix sort of the fix the rest of this stuff. We've got to add the ability to change the size of the font as well, right? So this hopefully will fix the bug that we had where the fonts were being written out improperly. But let's verify that first. So there's run the test asset builder, and let's take a look at what we've got. We'll go ahead and see what happens now if I run the actual game. There we go. So now let's see if we can pick a different font. Let's go in here and see maybe in handmade.cpp. What I'd like to do is say when we go to pick our font here for the overlay cycle counters and that sort of stuff, we need to find the font that we're actually going to do. Debug text line. Here's that push font with the font ID. So I'm going to take whatever font it was getting from the font ID. When we do the weight vector, I feel like that wants to be set now so I can pick which font I want. So yeah, if I do that, I want to set the font type. And where exactly is that asset vector? It's .e. So there it is. Font ID. There we go. So that weight vector, I want to go ahead and set the font type thing to like, I want to make sure I get it. And then I want my match vector to be, you know, whatever that debug value was there. So font type debug. So we'll grab that out. And then we'll see if we get a different font. And we do. Lovely. So that's great. That lets us pick our fonts now. By just using the tag system, we can set our tags and get different fonts out of it. And that's exactly what I wanted, because I believe, at least I believe, that that is a different font. Of course, it's hard to always know. Let's double check. Yeah, so we can get different fonts, and that's the party. Great. Everyone's happy. Everyone wins. It's fantastic. It's fine. It's totally fine. So now I want to make it so that I can specify the size that I actually want for these fonts, because right now when we load a font, I think the size is just hard-coded into it, right? We just, in the load font, we never bothered to make it so that you can pass something in. We just set it to something. So let's just say that this is the pixel height here. And then we'll, you know, go in somewhere and wherever that height value was, we'll put it here. we're going to go ahead and make all our calls to load font actually specify that value, right? So we had 128 before, so we'll keep that. But then for our liberation mono, I don't actually know what am I actually using here? 11 point? Well, that's 11 point. I don't know what the pixels are. I don't know. We'll just try saying 12 pixels high, but I have absolutely no idea. So hopefully that'll do something resembling anything, and I don't know. Well, we'll find out. All right, so let's see what happens if I run it. Oh, right, we're still using the Arial there. So now let me switch it back to the debug font and see if we get a smaller font that's one that we could, debug with a little bit better. All right. So that may be a little too tiny. That's a little too tiny even for me. And, obviously you guys are in a situation where you would see even less than I can see at this point. So that's not great. Not great. Not great. So let's just give it a little bit more room. Give it a little bit more room. For the sake of the stream, let's go ahead up to 20 and see if that helps at all. All right. So that's a little bit more reasonable. I don't know if that'll be super readable on stream, but since this is our debug display, I think we're just gonna have to live with the fact that you got to be at 1080p or something if you want to be able to read the debug display with me. It's a debug display, people, okay? It's got to fit a lot of information on the screen if it's going to be useful. So that's just how it's going to go. You're going to have to live with it. But there we go. Now we've got our stuff looking pretty correct. You can see that game update and render, like I've talked about before, is wrong because, of course, it stays open because the renderer is the thing that's actually drawing the debug display. So like I mentioned at the end of last stream, we got to do some stuff to actually get these to be correct for profiling the render as well, which is obviously something we want to profile. But our one call that we know that is being made and completes is in here. You can see that it's got its cycle counts and the cycle counts per hit, and it's got the number of hits as well. So that's pretty handy. And if I go in now, we can start to kind of see what would happen if we wanted to start using this a little bit more seriously, our little timed block function, right? So here we are in handmade.cpp. I could start to add profiling to this very, very quickly now. I don't really have anywhere in particular that I want to profile, I suppose. But, let's say we wanted to start profiling things like, probably not going to be in this file, right? They're going to be in somewhere else. So let's say we want our sim region stuff to be profiled, and so we're just going to start profiling this stuff, right? So here's our move entity call. Let's time that, right? Here's our entities overlap call. I don't know. Time it. Why not? Speculative collide. I don't know. I mean, I'm not even really pretending to be reasonable at this point. I'm just kind of spamming these guys in here because why not? Guess what? We can do this now because we have the power. So I'm just spamming these things in anywhere I want to. I don't care. It's fine. It's all fine. So we'll put those in there, and now we'll recompile. And again, this is exactly what I wanted out of the debug system, because now we just run it, and hey, look, now we can see like where everything is happening and what's going on, right? So we can immediately see what our cycle counts are through all of our code. We can kind of see what's going on in there without having to like stop and do some kind of a profile run or something like that. And I can keep going like that in anything that we've got in here, right? I can keep going for whatever whatever stuff we've got. So I don't know if Handmade entity's got anything in it. I don't think it really does. No. Let's see. Handmade. What else we got in here? Handmade. Asset audio math random sim region handmade world.cpp. So let's see what's in there. Change entity location, we'll time that. Change entity location raw, we'll time that. Anything in here that's got other stuff? Get world chunk, totally time that. Let's see what else we got. Render groups. We probably want to time those, right? And optimized and all that stuff. But we've got some stuff to talk about there. But I'm gonna drop those in there anyway, because we might as well drop them in there. Like audio and the render groups, we might as well put in there. So let's see here. We've got play sound. We'll time that. We've got output playing sounds. We'll time that. Let's go ahead and do the render group as well. Right, render group. What do we got? Let's see, draw rectangle. We'll time that. Sample environment map. These aren't even really getting called at this point, but that's okay. Draw bitmap, sure, just in case. Change saturation. I don't know what that does. Probably some stuff I did because someone asked me on the stream to do it, and that's fine. Put this in here. And let's see what else. Render group to output, tiled render group to output, timed block. I'm just putting these everywhere. Just try and stop me, you know? Just try. I dare you. Begin render, end render. These are just the pushes. Get render entity basis P. Probably not necessary to time, but why not? All of the pushes here, we can do that. Sure, we'll time it. Why not? Anything else here? Okay. So now we've just basically, we did exactly what I said I wanted, which is it's free now for us to just time those things. We can spam them everywhere. And now we just have a ton of heads-up information, right, that we can use. But there's a bunch of problems. So first off, like I said, we've got one here that you can see that I talked about before, which is that the timings for anything that encloses the rendering are just totally wrong, right? Because the block that's timing them is open when it actually gets printed. So we have to do something to delay our timings by like one frame and like put them somewhere and print out the timings from the previous frame, for example, so that we can have those blocks be closed before we go to try to access them. So we need to do that to finish game updated render. So that's one problem. Second problem we have, right, is that when we go to do some of these other performance counters, we're not thread safe. So anything that might be called from multiple threads could have totally garbage results, right? Because if two threads open and close the blocks together or whatever, we have no idea what's going to go on there, right? And furthermore, those threads could be running, doing something while we're printing it out, which means the block could again be open. So we have more work to do if we want this system to be able to handle everything. And maybe we don't. Maybe we'll get to something and say, okay, this is a little too hard. Maybe we won't try to, make it work with that. But we should at least start trying to push a little bit further in now to sort of shore up this system a little bit more completely, right? All right. But even if we didn't do any of that, this still gives us a tremendously more useful picture, right, of what we're doing. Because if you can see here, we definitely have, if you look at what's going on, you can see that already we can see a bunch of cycle counts, a bunch of hit counts. We know like how many times before we had no idea how many render elements we pushed per frame. Now we know we push about 760, right? We know it takes about 38 cycles to push one of those, blah, 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 right? So there's actually stuff, and I mean, keep in mind that the cycle counts, this is not an optimized build, so the cycle counts are not that meaningful because those cycle counts would go down if we compiled in optimized mode, so there's that, right? But, at the very least, we're already starting to get some more sort of a feel for what our program's doing, which is exactly what we want from this debug code. Even just that very little that we added yesterday already gives us a tremendously more insight into what's happening, right? So the first things first, let's take a look and see if we can find or think through some ways in which we could address some of these problems. At the very least, I think we should be able to solve the one of something's open during the render, because all we have to do is delay our results by 1 frame, right? So let's see if there's anything that we can do there to make that happen a little bit better. So right now, what happens is when we do our overlay cycle counters, that is the thing that does the reset. So what happens here is when we actually call into this, everyone who's going to be going to have the cycle counters overlaid had better be closed by now. So what we need is we need a way of having that sort of closure happen. We need a way of having that sort of heartbeat do some kind of like a copy, so that every time at the end of the frames it does like a copy of that memory, so that we know that it's not being used. It's not in the middle of being used. So, thinking it through, I think let's talk about this on the whiteboard, because I think actually there's some kind of creative things we could do here. I think, you know what, I think I take it back. Let's start with the threaded one. Let's start with the threaded one instead, because I'm kind of interested in thinking about the threaded one first. So let's do that. Okay. So here we are. It's day 178. So let's do thread, safe, performance, counters. All right. So thing number 1, right? Take a look at the way that I implemented the performance counters here, because it's not the smartest way that we could have done it. So do you see what I did? What I did is I add the hit count. That's fine. But when I do with the RDTSC is I just take the cycle count, I subtract first the RDTSC value, then I add it back in. And what that's essentially doing is it's subtracting the start time from the end time, right? Well, that means that if another thread were to come in here at this time and read what the cycle count was, they'd get a completely ridiculous value, because it's using that as like a temporary buffer. Okay? So what's happening essentially, is you can imagine. Let me try to give a little bit more maybe of a specific thing there. What we have is we have our total, right? And we do our total minus the clock value, right? And we write that out to the new total. And then we do our total, right, plus, this is like clock start. Let me write this in a slightly more mathy way. We subtract out the start value, right? And that gives us, I suppose, our T1. And then we take our T1 and we add in the clock end time, and that gives us our T2, right? And so if we expand out what that actually ends up being, the goal here is to end up with CE minus CS, right? The starting clock time, the ending clock time minus the starting clock time is the delta clock time, right? That's the delta clock time that we actually want to add in there. How many clocks elapsed? Well, we're counting on, we're doing that through here, but that means in between here, any thread that views this value, even if we did everything properly, any thread that looked at the value would get T1, right? But T1 is not valid. T1 is never an actual total thread performance time. T0 was, and T2 is, but T1 is a valid clock time minus some absolute clock value. It's totally bogus, right? So we just want to make sure that we never have a T1 in there. We want to make sure we go right from T0 to T2, so that any time you observe the thread value, it's correct. And that's really easy for us to do, right? All we have to do is do the start cycles here, like so. And then instead of modifying the cycle count, we just don't have to ever write to that, right? We would never actually have to do that. We could just go ahead and say, all right, take the cycle count here and add to it whatever the start cycles was, which we'll record. Whatever the start cycles was, subtract that out. There's the delta cycles. And then we'll just record, we'll get that. We'll take the cycle count and we'll increment it by this. So now we would know that no matter when another thread goes in there, it's going to be correct, right? So that's all good. All right, but we've got another problem. We've got another kind of little ugliness, right? And the ugliness is that if you take a look at what happens here, and we've got a to-do thread safety thing here, if you take a look at what happens, two of us could be trying to modify the hit count or the cycle count at the same time. Now, we don't care if two people are modifying these values, because these values are just always going to get overwritten with the correct information. So it doesn't matter at all, right? It does not matter in any way. It's totally superfluous, right? But the hit count and the cycle count, we want to modify atomically. So what we want to do here is we want to do a locked increment of the hit count so that it can kind of accumulate. So what we'd rather do here is we'd rather have our handmade intrinsics, and now I'm going to feel stupid for removing it because we had atomic increment here and I think I removed it. Oops. But what we want to do is go, okay, atomic, right, increment, and we probably want to do, I don't know, how many cycles is going to take? Is something going to take more than 4 billion cycles? Probably not. So we could do 32-bit atomic increment, right? We could do atomic increment U32. We could say what we want here is the record cycle count. I'm sorry, the record hit count. We want to atomically increment that by this, right? Or this is really just atomic add, right? So we want to do an atomic add. We want to do the same thing for the cycle count, right? So atomic add the cycle count. Cast this to U32 like so. And so as long as the processor supports atomic add, which they all do, we don't even have to do any kind of compare exchange locking, none of that. We just say, okay, we need to be an atomic add, and off we go. Okay? It's very, very straightforward. And let's go ahead and do this here, delta time. Let's go ahead and pull that out like so. Just so we can see very carefully where the atomics are. So I just need that function, right? I need atomic add U32, the volatile, and the add end. When we do the interlocked, I think this is just the interlocked add. I think that's all we really need, add end. And there's the result. Off it comes. I think that's probably all we need to do, but I'm not sure. Let's take a look. Interlocked add. Interlocked compare exchange. Intrinsic functions. Excuse me. Please load up my intrinsic functions. Add. That's not the. Didn't actually want those. Those were not the ones I wanted. I wanted the other list. Not for MIPS. Who still programs MIPS? Seriously? All right. So let's see here. Let's get some interlocked compiler intrinsics. Oh, wait. Is it up here? There it is. That's the one. Interlocked exchanged add. Interlocked exchanged add. Is that a good one? Do you like that, compiler? Yes, you do. Okay. So I'm going to take a look at interlocked exchanged add with the underscore. Like so. I just want to see what it returns. This doesn't tell me what it returns. Why does it not tell me? The initial value of the variable pointed to by the add end. So it's the one that comes back originally. So this note Casey returns the original value prior to adding. And I'm just going to take a blind guess at this one. Well, let's get this one right first, but I'm going to take a blind guess at the LLVM one, and then the people on the forums can tell me what it is, because I've implemented before on LVM, so I should be able to maybe get close. N64, yes, that's fine. There we go. Cannot convert. Oh, the cycle count was a U30. It doesn't need to be anymore. It does not need to be at all. Which means we've actually got a pad in here. We could, we could do something creative with it. Yeah, we could even... no, we probably... Because the hit count's probably could in theory wrap if we were counting something large. So I'm not gonna try to pack that down further. Right? You could imagine doing... Oops. You could imagine doing that and getting it down a little bit further, but I'm just not. I'm just not gonna do it. All right. So let's take a look at this now. That certainly doesn't look good. All right, so we're not quite there yet. We've got a little bit of work to do. It's true, but that's totally fine. So what exactly have I ruined? What kind of a life have I ruined for us? What have I done? Let me just go back in here as well. I wanted to do one more thing, which is, let's see, in my printout routine. In here, I also want to change these guys to be... I actually want to change these guys around slightly. So what I would like... do it that way. What I would like to do here is I'd like to do a exchange of these. I'd like to do an atomic exchange of these guys so that we can actually do the reset atomically as well, if that makes sense. Now, we could actually do something kind of crazy. Oh, man. I'm kind of thinking that we could do something kind of awesome here. So what we could also do... I won't quite do it yet. So you know what? I'm not going to quite do this yet. I'm not going to do it yet. But we're going to do it. It's just I'm not going to do it yet. Because there was a bug in my thing before. So we're not going to do it yet. But then I'm going to do it. We're totally going to do it. We got 10 minutes left. We're so going to do it. We're so totally going to do it. It's not even going to be funny. So let's find the bug first. Let's just find the bug first. Right? So, okay. What do we have going on here? That's probably just because we're printing out i64s when these are not i64s. So let's get rid of that first, and that'll fix that. Okay. And then let's go take a look, and we'll see that looks a little more reasonable, certainly. Now things are looking pretty calm and fun. Okay. So yeah, all right. It's totally fine. So now what I'd like to do is I'd like to make sure this is atomic as well, because why not? And what I was thinking is we could actually make sure that the cycle count and the hit count are actually always updated atomically together by just merging them into one U64. So we could basically, do something where we have the hit count on the top and the cycle count on the bottom, or something like this. And furthermore, that means we could steal some bits. So the hit count and the cycle count could actually not both be 32. If we wanted the cycle count to be able to go over 4 billion, we could. Now, I don't know if we do, but we could. It leaves that ability open to us, right? So how that would work is we'd have our hit count here, right? And the hit count, excuse me, would just get stored. So hit count equals hit count init, like that. And then instead of doing the atomic add U32 here, we would not do that at all, right? We would just snap the start cycles. That's the only thing that would happen. We would snap the start cycles. Now there's another thing that's kind of annoying here. Again, this is just the part about, I wish we could sort of pass something to the destructor of this thing, like kind of say that at the bottom I want to do something else. I'd have to think about if there's some way we can do that. I don't think there really is, but not an issue at the immediate moment. But when we do this delta time here, right, what I can do now is I can say, okay, take the delta time as a U64, then OR in the hit count as a U64, shift it up by 32 bits, right? Then we just do one atomic add U64 to the hit count, cycle count, with just the delta of both. Does that make sense? And so then, instead of our intrinsic being about a U32, it's actually about a U64. Does that make sense? So then when we do an interlocked exchange add 64, and I guess I don't really know what it wants us to pass for that on MSVC. Just an underscore underscore in 64. Okay. That would allow us to be completely atomic the whole way through, which is pretty sweet. So then we have our hit count here, we have our cycle count here, and that's just going to be, you know, and I'll grab this out here. So we've got the what's that thing called? Handmade debug, and we'll just hit count, cycle count, right? So the hit count, cycle count, we grab it out like that. Then we say, okay, whatever the hit count is just going to be this thing shifted down by 32, right? And the cycle count is just going to be that same thing with the top masked out of it. So and OX FF 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 FF, right? Just get those bottom bits. So then we've got the hit count and the cycle count. We've extracted them, and now we just use them as if we had stored them that way to begin with, right? Pretty easy. And now for clearing, we also just do counter hit count cycle count equals 0. So we just clear one value and it clears the whole thing, right? And so in theory, that is now allows us to be completely atomic with the add, which means that now there's no possibility of, you know, getting the cycle count with the wrong hit count and reporting the time wrong. Because when we divide by the cycle count to get the number of cycles per invocation, if the hit count was off by 1 because someone's block hadn't finished updating the hit count but had finished updating the cycle count, we would have this sort of like misreport for just that one, right? So we don't have that problem anymore. Or I should say, we almost don't have that problem anymore. Our read from this thing and our reset are not atomic. And we would like those to be, because we don't want to read from it and then reset it after and miss an invocation, because then we'd miss one invocation of the thing, right, that we were trying to count. So that we can also fix by just having an atomic exchange, right? So we have atomic exchange U64. That's going to take a U64 volatile, and it's going to take a U64 new. It's essentially exactly the same as compare and exchange, but instead of ever doing a compare, it's just always going to do the exchange. It doesn't care what the original value was, it's just going to swap them no matter what it is, because that's all we actually need it to do in this circumstance, right? So now we can call atomic exchange on this guy. So that'll do the clear and give us back the original value, and that makes sure that now we're always reporting, we're always clearing as we do the report, so that nobody is ever going to be able to get in there in between that and have us overwrite it when we clear, right? Okay, so let's take a look and see if that works now. All right. So now, I think we are actually printing things out in a relatively sane fashion. I think we're thread safe, right? I think no matter how many threads are pounding on that at the same time, it's going to get summed properly. And that's fine, right? Now there's some things we might want to do to get better information about that thread stuff, but as you can see, we now have pretty stable reporting. All of our counts are lining up nicely, our cycle counts look plausible, so we're getting there, right? We're getting there. So that's pretty good. And it's very low overhead at this point, There's very little going on in that time block thing. And really, there's only one atomic operation, which is right here, and, you know, those atomic operations are not particularly expensive. So we're in good shape. This is pretty cool. I think this is pretty darn cool. But we're not quite done yet. So when we print these things out, we are only printing out the debug records main. We also, remember, have the optimized one. So in here we've got a time block, and we're not reporting that one yet. So what I'd like to do is go ahead and expand this out a little bit, right? To do sort of a debug output debug records. I don't know, something. Where I can pass which array I'm trying to do, and that way it will be able to be called twice, right? So if I do that, and I have a here, oh, you know, I should say to do stop using standard IO, because that's another thing we've got to do. Because technically that's a library. Even though it's built into C, it's still a library. And I don't like using libraries. That's not really the point on Handmade Hero, so we want to get rid of that. Anyway, so I want to pass here whatever the array count is, so I need like a count, right? Counter count, ironically enough, and a debug record pointer, counters. And then here I can just do two of these, output debug records, output debug records. So I can output the array count for debug records main, and the array count for debug records optimized, like so, and pass the pointers as well. There we go. So in here, then I can just do counter count, and I can do counters. Oops. Counters. And now we can print out both, I believe. Let's see. Oops. Here we go. Debug records optimized is an undeclared identifier. Well, guess what, my friend? A, you're right. That's true, because it's right down here, I believe. But I'm just going to go ahead and pre-declare that for you, so that you can print it out. You know, the problem is, though, we won't know what the count is. We won't know what the count is, so we're going to have to do one more thing, actually. Right? We're going to have to do this. Debug records optimized count equals counter, right? And then that. And I guess this is going to have to be a const, because there's no other way to do it in C without saying const, I believe. Right? Am I right about that? So there we go. Unresolved external symbol, unsigned int const debug records optimize count. It's right there, though. Why are you not accepting it? Oh, because I just didn't extern it. All right. So now that we're linking up there, looks like we're doing okay. Now, that's a little odd. Why is draw rectangle quickly showing up twice? That's a bit odd, don't you think? Oh, I know why, because it's got two pieces to it. Yeah. So what we probably should do is do something like draw. We should probably, when we print this stuff out, we probably should do something like printing out the line number as well. So then we can see that there's two different ones, right? Lovely, isn't it? Running with all those threads as well. That means we could do other stuff too, right? We could even go a little bit more hog wild. I gotta go to the Q&A here. We're pretty much out of time. But I should say, well, if we're thread safe, right? We can just go ahead and put fill ground chunk in there, right? Although I guess that doesn't really make any sense because that doesn't do any work. So let me rephrase that. Put it in there. How about handmade asset? What about in here? Load asset directly. We'll put that in there. You know, find block for size. Acquire asset memory. Why isn't that timed? Should be timed. Right? Of course it should be. Everyone knows it should be timed. Load sound. Load bitmap. When it's free to do stuff, you do it, right? And so you want to keep that. You want to have that sort of path of least resistance be the right path, because if the path of least resistance is the right path, then you're always on it, right? It's never drudge work to do the right thing. Boom. And so as we walk around, you can actually see those guys come on there briefly, like as the ground chunks get filled, right? That's what that's showing. And so that's another hint too of other stuff we're probably going to want to do, because those things are only on there very briefly. We'll want ways to be able to see what they were on previous frames, right? All right, so that's good for today. Let's go ahead and go to the Q&A. If you have a question that you would like to ask about what we did on today's stream, please put it into the chat with a Q: in front of it so that I can see it. And SZ, this was again pretty awesome. Thank you. You are most welcome. Thanks for tuning in. The Buzzsaw. Wouldn't a union be helpful for that hit count, cycle count? It just seems unnecessary having to remember their offsets and or lengths. When you're talking about an atomic exchange, I don't really want to deal with that stuff. Like when I'm doing stuff like using atomics, I want to micromanage that because I just don't want to have to think about what the C compilers might have done or what the C++ committee in their infinitesimal wisdom might decide to do with the union that messes me up, right? Let's see. Elvin, yesterday I asked about preprocessor constants other than file and line, etc. I did some searching and found about time and date. Maybe it's useful for us to include a time date stamp in some of our logs. I mean, maybe, but remember, the time and the date are the time and date of the compilation. So it's not particularly useful for us to have that, other than probably, maybe we bake that in just as a thing when you're like, if you're trying to report a bug, because so you know which like build it was or something. But it doesn't really help us probably beyond that. Can you align the text into columns with %32s in the sprintf or something? Yeah, I mean, you could do, I'm assuming you could do something like that if you were so inclined. Is that the actual syntax for the string width, though? I don't actually remember. So if you want it in columns, the cycle count's going to be tough, right? The cycle count's going to be like a bunch of things. Let's see here. Still not quite right. Is that more what we're looking for? I need to remember to go make loop live code editing work with a debug system, because it's not much work to do that, but so yeah, there you go. Elvin, you mentioned yesterday that destructors are called when the scope of the object ends. I just wanted to note, it seems that if you use it to exit a function instead of return, then the destructors won't get called. If you use what to exit a function? Like, what do you mean by if you use it to exit a function? Danny McGee, will you marry me? Unfortunately, I cannot. I am already married, and Seattle, well, Washington State, and I guess the federal government in general does not allow polygamy. In fact, Utah wanted to have it when they entered the union, right? I believe. But the federal government said no. That was one of the conditions of joining. So you can only have one spouse. Panic 00. Won't RDTSC give wrong results if your thread is preempted and scheduled onto a different CPU between the constructor and destructor calls? Yes. Well, okay. So, yes, it does. But, there is a but. If you are concerned about that, which I am not particularly concerned about, because, you know, that'll just show up as a blip, right? If you are concerned about that, you can actually let me rephrase that. So that is what I want to know, right? I want to know that a blip occurred, and I want to know where it occurred, and then I can later be like, oh, okay, it was an operating system task switch or something like that. That's all fine, right? But if you're trying to time things and you want to take the context switch out of the equation, you can't do it entirely because it's going to mess with your cache and all that kind of stuff. So it's not like you can completely remove it. But you do have the option. Windows actually does a save and restore RDTSC thing. It's like get thread cycle times or something like this. Windows get thread cycle count. I don't remember. Here it is. So what this guy does is... oh, it's not that one. It's this one. No, it's not that one either. Which one is it? There is an actual call you can make to get the thing that you sound like you want. And I just can't remember what it is. But trust me, it's in here somewhere. They added it at a particular time in Windows. There's where they'll actually save and restore the thing. And it's not. It said that one says it's not what it is. That one says. I don't remember. I'm sorry, I just don't remember what it is. You can get the information you want. They added a thing to Windows that will save the RDTSC when the task gets switched out, and so it knows the amount that was used and will account for that. So if that's really important to you, just go. You could probably just search online or something and find it. But there is a way to do that in Windows. I don't know if there's a way to do it in other OSs. Manny Slane, are you working any other games other than Handmade Hero? Yes, I have some work I'm doing on The Witness just at the end here for some stuff. And then I also am working full-time on a game, a different game during the day at Molly Rocket, which hasn't been announced yet. Twitch makes me itch. General important question, do you have any general advice for optimizing code performance, multi-threading, algorithm complexity analysis, etc.? Go watch the streams on optimizing that we've already done. That's my first set of advice. We didn't do like all the optimization stuff. There's more to come, but go back and watch the ones on optimization for an intro. Elvin, sorry I made a typo in the previous question. You mentioned yesterday that destructors are called when the scope of the object ends. I just want to note, it seems that if you use exit to exit a function instead of return, then the destructors won't get called. So just to be clear, exit doesn't exit a function. Exit exits your application. So the reason that the destructors don't get called in that case is because you've terminated your process. So obviously the destructors can't get called because it's been terminated. Does that make sense? Exit doesn't exit a function. Exit closes the entire app. Wistesso, the values are pretty hard to read when they're changing literally every frame. Wouldn't it be better to average them? Well, I wouldn't say it's better to average them necessarily. But as we sort of go forwards with this, you'll see the stuff that I'm going to do. I have a bunch of things we're going to do in terms of visualizing those values. So yes, but we haven't gotten there yet. Panic00, have you considered keeping the timers in thread local storage instead of using atomics every time you write them? Well, first of all, I don't think that would... Ooh, that was not good. I may have just spilled a bunch of water on my keyboard. May have spilled it. Let's just say, well, may is probably the wrong term. Definitely did might be a better way to say it. You know, let's see how it responds. So yeah, man, that was unfortunate. Apparently the keyboard is still working, which is odd, but lucky. So first of all, I would ask why you want to do that. Because thread local storage is only available on certain platforms and involves a bunch of things that you may or may not want to do, right? If we did them in thread local storage, you have to answer the question of how do you get them out of thread local storage, right? When do you do that? Who is the thread that would do that? Do all of your threads then lock up on a single debug pull point? And if so, does that ruin what you were trying to observe, right? So think about what that means if you're going to put them in thread local storage. And then think about the fact that atomics are free. I mean, they're almost entirely literally free. They don't cost you anything, right? Most of the time, they're like a few cycles. So, you know, putting them in thread local storage doesn't sound like a very good idea. It actually sounds like actually impacting the performance quite a bit more, perhaps significantly more, than using an atomic. Cuber Caleb, are lock-free data structures worth the time they take to write? That depends on the circumstance, right? Obviously, if you have something that's performance critical, then you may want a lock-free data structure. If you don't, you don't. Terry Roards, do you think it would be worthwhile to make the time records hierarchical like a call tree, and how would you go about it? So I don't really think that it's particularly useful. I mean, typically that's for people who don't know how their own code works, for the most part. Once in a while, there's a reason why you might want to do that where you don't really know on whose behalf something is being called. But typically, I don't find the hierarchical thing particularly necessary. Now, one thing that is useful is when you know that something inside something else is taking some of its time, to subtract that time out. Sometimes that can be kind of handy. But the problem with that is if you're trying to track hierarchical calls, you end up in things that, you know, that is something that may require thread local storage to do correctly. So you have to be really sure that you want it. Because if you aren't careful, you'll end up sort of impacting your, making the thing a lot more intrusive to get that. Now, we could try. I haven't thought too much about it in a while. So I'd have to think about, you know, if there's some ways to do... I mean, you know, on a platform like Windows where there's thread local storage, it's probably not very expensive to do. So we could do the tracking without it being like a huge deal, right? So yeah, I mean, we could consider it. We could consider it. On platforms without thread local storage, without reliable thread local storage, it would be a bit of an ugliness, I think. Can you explain the difference between mutexes and interlocks? So when you say interlocks, you mean like the atomic add and stuff? So yes, I can. Um, but I guess those terms are often kind of used. A lot of these terms are used somewhat imprecisely in certain scenarios, I guess I would also say. Um, so it's worth noting that you kind of have to really be precise about what you're talking about. But all right. So inside the processor, we've got cores, right? So here's core 0 and here's core 1. And these cores have caches. So inside the core, here's the L1 cache for core 1, core 0, and here's the L1 cache for core 1, right? Now what's going to happen on an atomic, the only thing that's going to happen on an atomic is that a particular core, the one who's accessing the atomic. So when I did that atomic add, right? The only thing that happens on that atomic is it's going to check to see whether this is in my cache, right? Whether the address that's being added, right? So, here's memory. And here's like the L3 cache or something, if there is one, whatever. Whatever the shared caches are. So I won't even say L3. I'll just say here's the shared caches, here's the exclusive caches, meaning caches only per core, right? So these are per core caches, these are the shared caches. When I do the atomic add, the only thing that's going to happen is the external part of the memory system, the part that's outside the cores. This core is going to say, I now need to own whatever that address is. So if we're going to do an atomic add to like this address of memory, right? It's going to make sure that I have exclusive access to that, which means that if this guy previously had it and had a value in it, he's going to mark his as stale, right? It's his non-exclusive, like someone else is using it, right? This is the Mezi protocol stuff that we talked about before that you can go look up. That's all that's going to happen. So it may involve a transfer where it has to like evict it from this guy and bring it into this guy's cache, right? But that was going to happen anyway, because if it wasn't in this guy's cache, he had to load it anyway to get it, because he has to add to it. So that's literally it. That's all that happens on that atomic add. It's going to do that exclusive. It's going to mark it as exclusive. It's just like if it was going to write to any other memory address. It's the same thing, right? So all it does is it makes sure that the only thing that makes it atomic is the fact that the read and the write happen together without allowing an eviction in between. That's it. Otherwise, it's free. It's really not an expensive thing, right? A mutex is not anything like that. A mutex has an arbitrary performance penalty to it that depends on the locking situation. So what a mutex is a mutex is like built on top of this, right? So understand that, you got this. A mutex is a programming construct built on top of this system. What a mutex does is it says, okay, I have two pieces of code, right? Here's code A, here's code B. They both want to do something, but that something is complicated. So they've got this piece of code. Each of them have some code in here, right? And we know that this code and this code cannot be run at the same time because they do some stuff that would conflict. So we want to make sure that only one or the other runs at that time. What a mutex is it uses the atomic operation of the processor to do something like have a memory location that's like a lock. And that lock is just set to 0 when no one owns it, and it's set to like some other value like 1 when someone does. So it'll do an atomic on that thing, like an atomic compare exchange, for example, to set it to 1. And if it gets back a 0 on the atomic compare exchange, it knows that it now owns the lock. So if A does that and sees that it gets back a 1, it will run the code, right? And B does that same thing, gets back a 1, knows, oh, somebody else holds the lock. I'll just sit here in a loop and wait until whoever is done with it releases it. And at the end, it does a set of the thing back to 0. So when A is done, B will then see it in the loop, go, oh, it's 0 now, do the atomic compare exchange to 1, and run my code. So a mutex is like an unbounded amount of time that has to go by. And you have to have loops to like sit there and check, right? And mutexes can be more complicated too. They can involve the operating system if you want to put like a thread to sleep. If the mutex is taken, so that you can give the processor time to somebody else while you're waiting on the mutex. So you can have operating system mitigated mutexes, which allow threads to give time back to the OS. So a mutex is like a way more, it's not even remotely comparable to this. The only time that it's remotely comparable to this is the case where the mutex is uncontended, and you still have a little bit more, which is you got that branch that's happening in there. But at that point, if you're just going to go through and you never contend that lock, then it's just going to be like an atomic. It does the atomic, the exchange, compare exchange succeeds, I run my code, I set it to 0 at the end. That's pretty darn close, right? So an uncontended mutex is basically, is not going to be appreciably more expensive. A contended mutex can be as much as this cost the entire time of this B will stall, right? I just want food. Wait about the values. Can you draw a graph out of them? Yes, but wait. You gotta wait. Be patient. Be patient and see. Elvin, no, save the Cherry MX Blues. They're actually Cherry MX Browns. TTBJM, will you be able to fix the click bug at the end of sounds with the debug system? Honestly, we could fix the click at the end of sounds probably without the debug system, but we just haven't bothered spending any time on sound. But yeah, we could make that a good excuse, we could make that a good test of our debug system. Like, could we make it easy to find that bug, right? Not a bad idea. Guitar Freak, can you still time a smaller section inside the code, or does it just work for whole functions now? You can time as small a section as you want. Just wrap it in braces. We already do that, in fact. So for example, Handmade, optimized. You can see here, timed block. This block starts here and ends at the closing brace down here. Right? Here. So that is a sub-timed block. So you can time any block you want, just enclose it in braces. Elvin, I notice you prefer to keep things on the stack and return by value. This helps with locality of reference and is more cache friendly, am I right? 1, is the stack size something to be concerned about? 2, when returning by value, is the time taken to copy the object and return it something to be worried about? Maybe when the struct is large. In this case, do you prefer to return a pointer to the object? Yeah, so typically pass and return by value, yeah. If the struct is large and the function is not inlined, then yes, you typically want to use a pointer or something. 2, for stack size, it's not really something to be too concerned about because I tend to not use that for particularly large things. Sparkly Guy, how do threads wait on lock-free structures? Do they? Well, it depends. On lock-free structures, a lock-free structure is really... it's a misnomer. I got confused about this, in fact, earlier on stream. And in fact, Fabian corrected me. He's, because he's more of a perf guy than I am. He knows this stuff a lot better than I do. I'm like more of a generalist kind of programmer, so anything that's perf related, like multi-threading and optimization, he's the go-to guy. And what he pointed out, because I was complaining about the phrase lock-free, and what he pointed out is like lock-free was a stupid name. It's weight-free is actually the correct term, introduced by Herlihy in this paper that I swear to God, if this isn't the best paper that anyone's ever written, it should be. I don't remember what his name is exactly. I'm sorry, how you spell it. There it is. Mitchell Herlihy. Let's see if I can get it here. Wait, free. Herlihy. There it is. I think this is right. Let's see. Yes. So Maurice. Sorry, man. I'm sorry. I don't know why I thought it was Mitchell. So this paper is insane. I have not had time because Fabian brought it to my attention only like a few weeks ago or a month or two ago when we were doing the optimization stuff originally. This weight-free synchronization stuff, this paper basically like just totally, it just totally pwned multi-threading. Nobody knew like anything about multi-threading at all. And then this paper came along and he basically just solved it all. He was just like, hey, guess what, guys? You know all the outstanding questions we had about multi-threading? I did them all. And I just stuck them all in one paper. Like, I know that sounds ridiculous, but actually if you go read the paper, it's like totally true. It's like, oh, it looks like I just pwned it and now we're done. And it turns out that he was just right. And so in this paper, he actually introduces all the correct stuff and he called it weight-free, and he's actually more correct. Lock-free programming has nothing to do, like lock is a dumb term and it doesn't mean what it sounds like it means. Weight-free is the more appropriate term, and what it's referring to is the fact that multiple concurrent workers will never get into a situation where they do not guaranteedly make forward progress eventually, right? They never get in a situation where they might stop making forward progress. And he explains like a bunch of these things, and he also goes through like what are the properties of a processor necessary to ensure that these are possible. And so this stuff is pretty great. He introduces the concept of a consensus number, which is brilliant. It's basically the idea that's how many different things could come to an agreement about the state of the world, right? And he basically proves that without compare exchange, if you only have like atomic increment or atomic decrement, you can't achieve a consensus number greater than 1, which means that like there are algorithms that simply can't be implemented on that processor, right? But atomic compare exchange actually allows you to have a consensus number of infinity, which means that you can have as many people as you want agreeing about the state of something using just that operation. So yeah. So anyway, point being, read that paper if you want to have your mind blown, because it's insane to think about how much crazy stuff he did just at once. Just like poof. So Maurice Hurley, I'm sorry I got his name wrong. My memory is not what it used to be. But there you go. And so if you want to know how threads wait on lock-free structures, actually think in terms of weight-free structures. Read that paper, it explains it. But the basic idea is that you make sure that when people do things, they're always only doing them for a prescribed amount of time and never wait on each other. They just do an operation and release, right? And it's, you can kind of see, he talks about how to do it with like a, you can imagine doing it with atomic compare exchange as well. It's relatively clear. So the stream is technically over, so let me just take a quick gander here. Gasto5, what's wrong with pointers to inline functions? Is that a joke? I'm not sure what you mean. How can you take a pointer to a function that doesn't exist? Right? An inline function is basically a macro. It just gets expanded inside whoever calls it. So you can't take a pointer to it because there is no, it doesn't exist in memory. Right? It just gets spammed out to everyone who used it. I'm not sure if you're joking. If you're serious, that's the answer. If you're joking, I don't know what the I'm not following the chat, so I can't tell. Elvin, why you skipped my questions? What question did I skip? I answer all your questions. Blurberry, did you get a degree in CS? No. What's your background on programming? That should be, HMHbot should answer that for you, but also you can go to the links underneath the Twitch stream would tell you that. And it looks like that's about it, I think. Yeah. Yeah. All right. Let's wind it down, people. Wind it down. Save. minimize, or try to minimize, attempt to minimize and fail. Close. Okay. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, if you pre-order the game, it comes with a source code even right now, even before the game is a game. You can follow along with just the engine building in the source code if you would like to. And you can do that on handmadehero.org just by clicking on this handy little button. We also have a Patreon if you just want to support the video series and pledge to it. You can do it there. It's always very much appreciated. We also have a forum site where you can go to ask questions, get ports to Mac and Linux that community members have done. You can look at an annotated episode guide that community members have been working on. We also have a tweet bot, so if you want to join the stream live, like perhaps you did today, you can go to the tweet bot and either subscribe to it or just check it periodically to see when the stream's going to be. It always has an up-to-date schedule on it, so that's a good place to go if you want to catch the stream live. That's about it. Tomorrow we will sort of continue our exploration of debug code. We sort of have the beginnings of it now, right? We've seen how to do one set of markup, and we have a nice little display that's showing how many times we call various functions and how long they take. That's a good start, but there's still a lot more we could do. It's not a particularly good view at this point. It doesn't really show us some of the information we might want. It doesn't show us information over time at all. There's a bunch of things we could do, so we can start to press on that a little bit. It also, we don't have any sort of other markup, right? All we can do right now is take timings. We can't see data very easily or memory. So we got a bunch of more stuff we can do. So over the next couple weeks, that's what we're going to be doing. So if you want to see us continue with that, right back here tomorrow, 5 p.m. Pacific Daylight Time, we'll be at it again tomorrow, adding some more features to that. So hope to see you there. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.